using these different properties. Okay, so our first example is simplify x squared minus 1 over x squared plus x minus 2. Okay, so we basically need to always try to factor. Anything with a squared, you always want to factor that so you can get some stuff that you can cancel out or add or subtract or whatever you need to do. So I know that the top is going to simplify to x minus 1, x plus 1, based on properties of perfect squares. And I know that if I did a t-chart for the bottom, I would get x minus 1, x plus 2. Okay, so you guys can do that on your own, the t-chart if you need to. And you can see right now easily that this would cancel out that x minus 1 on the top and bottom. So we are going to write our final answer just as x plus 1 over x plus 2. That's our final answer for that one. In that property, we used canceling out. That's really all we did for that one. Okay, the next one is multiply and simplify. So this one is giving you a hint. We're going to have to multiply. So this is a long one. It's x squared plus 2x minus 3 over, over x squared plus 8x plus 16 times 3x plus 12 over x minus. Okay. So what we need to do is just basically factor everything. So I can tell that this, I'm just going to write it how, I know that this top, this numerator in the first fraction is going to have to be factored like this. I know that the denominator is also going to have to be factored into something like that. And then I know this second fraction, this x minus 1, is going to stay on the bottom, just like that. And I know the top needs to be factored in some way, and I'll do that on this side. Okay, so let's just start with the first fraction. If you did a t-chart for let's see, this one right here, okay, your answer is going to come out to be x minus 1, x plus 3. So you can do a t-chart and see if that works. And then on the denominator, you're going to get x plus 4, x plus 4. Okay, you could write it as x plus 4 squared, but we're not going to do that yet. We're going to combine at the end. Okay, and then now I'm going to move on to the denominator over here. And basically there's no squared, so we can't, there's no x squared, so we can't do a t-chart, but we can pull out a greatest common factor. So the greatest common factor that's both in 3x and 12 is a 3. And what's left on the inside is x plus 4. Okay, and then that, we need to multiply all that together. So we're going to multiply first and then simplify. So basically you can just rewrite the top all multiplied out. That's going to be x minus 1, x plus 3, and then we can put our 3 up here, and then our x plus 4 right here. So we're just multiplying it all together. All right, x plus 4, x plus 4, x minus 1. Okay, cancel as much as I can. So I can cancel this x minus 1 and this x minus 1. X plus 4, x plus 4. So what's left is 3, x plus 3 over x plus 4. And you need to leave it factored as much as possible, just like that, okay? All right, the next example is divide and simplify. So this one is dividing, using that dividing property that we said. All right, the first thing I'm going to do before I forget is flip the second fraction and change it to multiplication before I do anything else. So I'm going to leave the first one the same, multiply, and then flip the second fraction. Now I can start doing exactly the same stuff I did on the last problem. I can start factoring things out. So I know this x minus 4 on the top is going to stay the same, and I know the bottom is going to simplify, is going to factor into two parts. Okay, and then over here with another x squared, I know that that's going to factor out, and the bottom as well will factor out. Okay, so if you guys do some t-charts on the side, you can figure out the second fraction pretty well, but the first fraction right here with x squared minus 4, that is a perfect square, so you should know that the answer is going to be x plus 2x minus 2. Okay, and then if you did t-charts for the second step, you should get, let's see, x plus 2, x plus 3. And then on the bottom, you should get x minus 4, x plus 1. Okay? And then we can start, now that we have it as simplified as possible, we can start canceling stuff out and then combine it as one big fraction. So I can cancel out my x plus 2 on the top and bottom. I can basically, that x minus 4 is basically in parentheses, so I can cancel that out with this x minus 4. And then I think that's it. So what's left here is on the top is just x plus 3, and on the bottom is my x minus 2 and my x plus 1, and then you're going to leave it like that. So that's your final answer. Okay. So that one's just like multiplying. You just flip at first. You flip first, and then you do it like a multiplication problem. Okay. And then the last one is, the last example is a double example. You're going to perform, you're going to add or subtract, and then simplify. Okay, so A is 3 over x minus 1 plus x over x plus 2. Okay, so whenever you add, you need to make the denominators look the same. So basically here you need a least common denominator, and that is going to just be, since x minus 1 and x plus 2 are two different things, you can just multiply them together and you'll get your least common denominator. Okay, so then we need to go change the fractions, and we need to go multiply the fractions up top times something that will make x minus 1 and x times x plus 2 the denominator. So I'll just show you how we do that. So we've got our 3 and our x minus 1 on the bottom, and we need that to be multiplied times x plus 2 in order to get that on the bottom. And then over here, I'm going to do the other one, x over x plus 2, and that one needs to be multiplied by x minus 1 in order to get that least common denominator on the bottom. So our new fractions look like this: 3 times x plus 2 over that denominator times x minus 1 over that denominator. And then you can just add, in order to add those together, now that the bottom is the same, you can just add those together. But I'm going to multiply that 3 throughout and then that x throughout. So I'm going to get 3x plus 2 plus x squared minus x all over our common denominator. And then I'm going to just simplify the top a little bit. X squared plus 2x plus 2 over that common denominator. And no need to multiply that out. Just leave it like that. Oh, I think I made a mistake here. Oh, I should get 6 right here. Sorry about that. And then this should be a 6 right here. Okay, and then, so that's adding. Now we're going to try subtracting. All right, 1 over x squared minus 1 minus 2 over x plus 1 squared. Okay, so basically I'm going to factor this out before I start doing anything. So I'm going to rewrite this as 1 over x minus 1, x plus 1. And then over here, I'm going to rewrite this as x plus 1 times x plus 1. I just rewrote it and factored everything out. And now I need to find a least common denominator. Okay, well, I know that I need to have 2 x plus 1s. And since this also already has an x plus 1, I only need to add an x minus 1. So that's my least common denominator. So I'm going to do what I did earlier. I'm going to write the fraction here. So my fraction is 1 over x minus 1 times x plus 1, and the only thing I need to multiply to get this least common denominator, the only thing I'm missing on the bottom is another x plus 1. Okay, so this becomes, actually I'm going to do the other fraction before I write out what it becomes. And the only thing I'm missing over here is an x minus 1, so I'm going to multiply times x minus 1 over here. Okay, so now I'm going to get 1 times x plus 1 on the top, and then I'm going to get my common denominator on the bottom. And remember, I'm subtracting. All right, now I'm going to just multiply everything out and then subtract. So this top becomes x plus 1. And then if I, because I multiplied that 1 out, and then if I multiply this 2 through there, that becomes 2x minus 2. And then I need to distribute this negative throughout, so it actually becomes minus 2x plus 2 on the top, okay? Make sure you get your negatives correct. All right, and then the other thing is it looks like you might be able to simplify this x plus 1 with the x plus 1 on the bottom, but that is not true because this x is its own term and this 1 is its own term, and that negative 2x plus 2 is another term that's all attached to it, okay? So we cannot cancel it out with the x plus 1 on the bottom. We can simplify the top, though. The top becomes negative x plus 3, and then we can rewrite the bottom as x plus 1, and we can actually, since we're done here, we can make it x plus 1 squared instead of writing that x plus 1 again, and then x minus 1. So that's our final answer. Okay, you could also write it as 3 minus x, and you could do the same denominator as well. Okay, so that is our final answer for subtraction. All right, make sure to take notes on this and upload these, and then do the assigned homework as well.